gravity. Our table of contents, which we can go over, goes along with our text features. This is our table of contents, so here are some things we are going to read in this book. What goes up must come down. The fabric of space, the effects of gravity, and pulling it all together. So that is our table of contents, which is going to tell us a little bit about what we are going to read. What goes up must come down. No one can deny the power of gravity. We can't see gravity, but we feel its effects every day. Imagine what life would be like without it. Trees, buildings, and cars wouldn't stay on the ground. Even the air we breathe would float away. Gravity is the force that pulls us towards Earth. It attracts objects to each other. In fact, all objects are attracted to the gravity of other objects. That includes Earth and the people who live on it. Earth pulls on us, and we pull on Earth. But what's behind this force? Finding force. Sir Isaac Newton was a scientist in the 17th and 18th century. Newton discovered 3 laws or rules that explain the way objects move. One of these laws tells us how a force, such as gravity, acts on an object. Without gravity, our lives would be very different. The fabric of space. Space is all around us. We move up, down, backwards, forwards, and sideways in it. We can't see it, but space is everywhere. Space is like a piece of fabric that never ends and stretches in every direction. Objects in space curve the area around them. Think of a tennis ball resting on a piece of fabric. The fabric bends under the ball, and a larger object, such as a bowling ball, pulls the fabric even more. A small marble on a fabric would fall towards the bigger ball. Gravity works the same way. It occurs when objects curve the space around them. And just like the balls on the fabric, objects in space fall towards each other. Going the distance. The closer 2 objects are, the more they are attracted to each other. When objects are further apart, the effect of gravity is weaker. Deep thoughts. Albert Einstein lived in the 19th and 20th century. He thought deeply about what might cause gravity. He developed the idea that gravity occurs when objects curve the space around them. More mass, more gravity. Gravity varies depending on an object's mass. Mass is the amount of matter in an object. Matter is what all things are made of. It's easy to confuse mass with weight, but they are different. Weight is a force of gravity on an object's mass. When you step on a scale, Earth's gravity pulls you down. This puts pressure on the scale. The more you weigh, the more scale is pushed. The number on the scale is called weight. An object's mass never changes, but an object's weight changes based on where it is in the universe. If an object is somewhere with lots of gravity, such as Earth, it weighs more. If it is somewhere with less gravity, such as the moon, it weighs less. Gravity is a force pulling this apple down. Measuring the force. Hundreds of years ago, Newton's discovered gravity as a force that can be measured. Today, scientists honor him by measuring the force of gravity in Newton's N. Just like length can be measured in feet, inches, and yards, gravity can be measured in newtons. So this is an illustration that shows us on the moon an elephant would be as light as a feather. This is a caption that tells us what's happening in this photograph. Here are some subheadings, and here is a description of what's happening, which would be a sidebar. Often bigger objects have more mass, but when mass isn't always relative to size, very small objects can have a lot of mass. And sometimes something very large might have less mass than something small. A simple example of a golf ball that has more mass than a beach ball. It's smaller, but there's more stuff packed into the space. Objects with more mass curve more space. They have more gravity. Objects with less mass have less gravity. Just think about a bowling ball and the marble. The marble falls towards the bowling ball in the fabric of space. It's the same with people and Earth. People have less mass than the Earth, so Earth's gravity is greater. People are pulled towards the Earth. That's what stops us from floating off into space. Also, think about when you jump, you go back down every time. To the moon. Space travel was only made possible by knowing how gravity works. Once scientists learned the strength of Earth's gravity, they figured out the force needed to overcome it, to escape Earth's gravity. A space shuttle must travel 40,234 kilometers per hour, or 25,000 miles per hour.